How about now? No? Okay. How about now? Okay, so when we do the first, how do we write aluminum bromide? What is it? Is it a compound or is it an element? It's a compound, so we have to do the what? Crisscross with the oxidation number. So when we look at aluminum, what's its oxidation number? 3. And bromine is a what? It's a 1. All right, so we have Al has a 3, Br has a 1, crisscross and bring our 3 down. Plus, all Our second compound was lithium oxide. We got a compound again. So lithium has what? Oxide has a 2 comes down. Yields. We had what? Lithium bromide next. All right. So lithium has what oxidation number? Remember, they're right here. Has a 1. Bromide has a what? What's going to happen to the 1s? They're going to cancel out. Plus, we're going to have aluminum oxide. So aluminum has a what? Oxygen has a, the 2's coming down, 3's coming down. All right. So all of those were compounds. So all of them have 2 oxidation numbers. So I crisscross every oxidation number. Is everybody okay with that? Okay. So to balance it, all right, what element do you want to start with? Who? Sure. How many aluminums here? How many there? So we're going to put what there? Okay. How many BRs did I make? How many there? So I'm going to put a what? Okay. How many lithiums do we make? So what I put here? How many O's did I make? How many O's? So it's done. All right. Number 2. So we have manganese 5 oxide. So manganese is Mn. Oxidation number is 5. Oxide has what oxidation number? I have a 2 and a 5. Plus, did it say chlorine? Fluorine. Okay. Fluorine. So fluorine is an element. What do you ask yourself? Does it get a 2? Is it one of the 7? Is it one of the 7? Yeah. Yes. So you put a 2 on it. Okay. Yield. What I put first in this? I put the manganese 5 fluoride. All right. So the manganese and then fluoride, you have a 5. And what's the oxidation number on fluorine? So we're going to have a 1 here and a 5 there. All right. Plus the last element was oxygen. So I put O. Is by itself. Is it one of the 7? Okay. So we put a 2 there. Now, all that's left is the balance. So, what do I want to balance first? Huh? What'd y'all say? Fluorine? Okay. So how many fluorines? How many there? So we're putting what here? And what here? Okay, so that gives us how many MENs? How many MENs? Okay. How many O's? How many O's? Can I get 5? All right, so let's pick something else other than F.
Amen.
Okay. How many MENs? How many MENs? So we're going to put a what? Okay. So from there, that gives us how many F's? So we're going to put a what? How many O's? How many O's? Okay. So the only one we got left to start with is who? All right. Let's start with him this time. All right. How many O's? How many O's? So we're going to put a what here? And we're going to put a what there? Okay. Oops, that looks like an S. All right. So from there, not a whole lot more attractive. All right. How many MENs do we make?
4.
So we're going to put what here?
4.
Okay. And that made how many F's?
20.
We put what here?
10.
There you go. Questions. All right. So the last one's just balancing. So when we check it out, we have a really tiny equation. Let's see here. There, that at least makes it bigger. I hit the wrong one. That's why I didn't make it bigger. That makes it bigger. There. All right. So from there, how many C's do I have?
4.
So how many do I have here?
1.
So I'm going to put a what?
4.
Okay. And how many O's? Sorry, not O's, H's. I'm pointing at H and saying that. How many H's? 10. So I'm going to put what here?
5.
Now, if you did this, you found that this had how many? Plus 5 gave you how many total?
13.
Can you get 13 here? No. So this is one that we talked about yesterday doing what to? Put a 2 out front because you got an odd number. So get rid of all of that and put a 2 out here. How many C's do we have now? So how do I get 8? How many H's do we have? So how do I get 20? Okay, so that made how many O's? 16 plus how many O's? 16 plus 10 is? So how do I get 26? Questions? Any questions about how to do that? No?
So why did you put the 2 out front again?
Because we got an odd number when we added the O's, and we couldn't put a decimal in front of the O2 to make it even. So if I get rid of that, we had 4 and we had 5. So how many O's do I have there? And I have how many O's here? So we get 13. What number will multiply by 2 to give me 13? There isn't one, right? So we've got an odd number and there's no way to fix it. So the way to fix that is to get rid of all of it and put a 2 out front. And that works most of the time, probably 90, 95% of the time. But if it won't, what's the next even number you could put there to try? 4. Okay? Anybody else have a question? Homework time? Okay. Notice that was opening 1. If you had openings yesterday, we could collect those and put them on my desk today since we forgot to do it yesterday. Or as they pointed out, I forgot to do it yesterday. I take my share of the blame. All right, stupid stuff. There they are. There are the answers. And Lewis here. Thank you. All right, have we checked them all?
So
So,
number 5
uh-huh.
is already down.
Yes, if you can either choose not to write any coefficients in it, like I did. You can write balanced out to the side, or some people like to put 1s in front of everything. So you can do it any of those ways. Can I turn it now? All right. There's the last of the balancing. Hey, Mark Devontae. I knew I was missing something. Okay. Yes, John.
Okay, so, if there was a loan that I had to do that. Doing that. If, you said that if you have one with like, for example, I'm just gonna go with that one. If you have one that has like six, and so you said you need to find that out.
If all of the coefficients can be reduced, not some, but all. So let's just say for a moment that this one you balanced had a 2, a 4, a 4, and a 2 originally when you balanced it. Okay? Then you would reduce to a 1, a 2, a 2, and a 1. But all the coefficients have to be able to be reduced by the exact same number. If you can't reduce all of the coefficients by that same number, you don't reduce the coefficients. Okay? All right. Do I need to work any of the 1 through 12?
Number 12.
Number 12. All right. Number 12 should be here. All right. Do that. And then that. That makes it a little bigger. All right. You have one SR. One SR. This 2 goes to O and it goes to CL. So you have how many CLs? And how many CLs? So they're all balanced. The only thing that's not balanced is your O's. So how many O's are here? So how do I get 6 O's? Yep.
But I thought you don't do nothing with the number inside the parentheses.
Only if it has the same polyatomic ion on the other side. Because there isn't a ClO3 to match it up to, you have to break that one apart. Okay? What else?
So if there's a ClO3 on the right side.
On the right side, you can put parentheses around it and not worry about it. You go scratch it out and balance them as whole units. And most of the time it works that way, but sometimes it doesn't, like this one. That's a type of decomposition reaction we're going to learn about. It's called a metal chlorate. Anybody else? So we're okay on balancing today. Nobody's wigged out about the quiz. All right, so if we go to the answers for, all right, there's the back side. And you had to do 1, 2, and 3. And then I'll turn to the next page for 8, 9, and 10. All right, so see how you did.
Could you parentheses from a CLF?
Sure.
Or
Sure. I told you, I won't take off if you have parentheses that aren't needed. I only take off if you need them and they're not there. I mean, I've even had people put parentheses around CL like that. I don't get bent out of shape about that.
Evan has my keys.
Oh, okay. So I don't get upset by extra parentheses that aren't needed. Anybody? Question? Okay, so this one's what? Is that 6? This one's 6? 7, 8? Okay, so that will be 8, 9, 10. I can't remember what I assigned.
8, 9, 2, 3.
Okay, so this is 8,
Yes.
9, 10.
These ones.
Yeah.
No.
Okay.
Can we go over to, I got about it. I got it.
These are hard to guess on.
I mean,
I'd be glad to do it. I'm just saying they're hard to guess on.
I kept trying different ways, and when I couldn't get it, I
You're
tried.
talking about like balancing it?
Yeah. And
Okay.
then like I got to against the balance, and I was confused because I didn't know. I even tried to learn it like the OH, that was confusing more. And so I was just like, maybe it's on the computer.
Gotcha. Yeah, HOH won't work in this case because you have an O in all three compounds. So it would just make life, it wouldn't make it any better for you to do it that way.
Do you take off if we don't reduce?
If you don't reduce the coefficients, yes, there will be a deduction. Today, because you are only balancing and that is your only function, it would be half. Okay, but on a normal other type of question, it would be much less. But because today is only balancing, you lose more for not reducing. Huh? Most of you will not have to worry about reducing. Most of you automatically balance in lowest terms. But every now and then, you will have an example where, like this one, let's just say for a moment that you did this and your coefficients were 4, 6, and 4. What do the coefficients 4, 6, and 4 reduce into? Yes, you need to reduce that. If that is your coefficients on the quiz today, I would expect you to recognize, oh, I should reduce those coefficients and get 2, 3, and 2. Most of you will not get that natural. You will get lowest coefficients. But every now and then, some people get higher, and you need to recognize that and reduce them. But again, you can only do that if all the coefficients reduce. If they don't all reduce, can you reduce any of them? No. Which is why I said it's not going to happen very often.
Why isn't there a 2 for subscript on number 10 for the Z and the O?
Because this has a +2 and this has a -2, so what happens to them? They cancel out.
But I thought the positive and negative didn't matter.
It doesn't. The 2 2's cancel out.
Yeah.
They're the same oxidation number. So even if you bring it down and you write ZN2O2, what happens to the 2 2's? They reduce. And you get ZNO. You're looking at me like I've left the planet.
I don't remember.
Do you remember doing C2O4? What do we do with C2O4? Yeah. Okay. So it's the same concept.
But would that make a difference?
Yeah, it will. A balance wrong. Okay. So if you have this, what should that reduce into? This was on the mini lab we did with the construction paper. What did y'all write that as? Yes, you did. And if you actually still have yours and pull it out, because I would almost guarantee that you did it correctly, that's what you did. Okay, it's the exact same concept. Because you have the same subscripts, they reduce. Okay?
Yeah.
All right, so if we do number, what was it, 10 for diamond, and I know somebody asked me for another one, but it's gone. Whoops. There we go. So, zinc hydroxide. Zinc is a 2. Hydroxide is OH. And it has a 1, so the 2 comes down. Yields zinc oxide, which is the one Caroline was just talking about. You get a 2 and a 2. Now, for me, I don't even bring them down. All right? When I recognize they're both the same oxidation numbers, what are they going to do to each other? They're going to cancel out. I don't even bring them down. Plus, water is H2O. Okay? Now, from there to balance, Diamond asked about writing water as H2O. In this particular case, writing H2O as HOH is not going to benefit you because you've got an O here and an O here and you got an O here. So in all 3 compounds, you have oxygens you're trying to balance. So that's why writing water as HOH is not going to help you. Okay? So when you look at this, you've got one zinc, so it's good. All right, how many H's? 2, so the H's are good. How many O's? All right, 1 O and 1 O. So how many O's do you have? So it's already balanced. Okay. Which one's 9? Well, I guess one before that because that was 10. All right, so C2H6 plus oxygen. All right, so if I give you C2H6, do not change the compound I give you. If I actually write a compound like that, I mean for it to be C2H6, so don't reduce it, okay? That's actually ethane plus oxygen and becomes CO2. How do I write carbon dioxide? Now, if you don't know carbon dioxide is CO2 and it confuses you to use old system, you need to memorize that. Plus water is H2O. All right, most people struggle with the balancing on this one. So how many C's are there? So we're going to put a 2. How many H's? So we're going to put a 3. So we get how many O's? Plus how many O's? So that's how many? 7. That's 3. Y'all have already done the math for me. 7. All right, can I get 7 right there? No. Okay. So if I can't get 7 because there's no number that multiplied by 2 to give me 7, what did we talk about doing a while ago, Almaja? Yep. So I'm going to erase this. I'm going to put a 2 out here. All right. And I'll get rid of this because we're going to need to do it again. So how many C's did I make? I'm going to put a 4. And how many H's? 12. So how am I going to get 12? Okay. So that made how many O's this time? Yep. 8 plus how many? 8 plus 6 is? So I put a what there? 7. What else? Tell me what 9 says so I know which question I'm looking for. The which one? Okay. So which polyatomic ion do you want to balance or element or what? Okay. So the first thing I'd do is this one's in parentheses. So like you said, I'd put this one in parentheses. Okay. And make sure they match. So the 7's inside, the 7's inside, which means there's a 1 on the outside. Okay. So from there, how many Cr2O7s are there? How do I get 3 over here? How many H's did we make? How do I get 6? How many chlorines did I make? How many chlorines are here? So I put a what? How many cobalts? There's 2. And how many are right there? 2.
So you could not put the Cl and the Cl3 in parentheses.
You can. The 3 just can't be inside the parentheses.
Okay.
But you can put the Cl in parentheses. It serves no purpose because Cl is an element, not a polyatomic ion. But I mean, if you put the Cl in parentheses, I'm not going to take off for it. I mean, you can do that. I just don't put or teach to put an element inside the parentheses. Okay, I only do it with polyatomic ions because those are the only things that really balance as whole units. Anything else? Nope. You need nothing today but a pencil and a calculator if you are weak in adding and multiplying. Because I don't want anybody to say that I kept a calculator from you and you couldn't balance because I wouldn't let you have a calculator. Otherwise, you need nothing. Even on a whole sheet of paper.
So we don't need no oxidation.
Nope. All you got to be able to do is add and multiply. What time is it? I gave you how many? 1, 2. You may not have past 9:15. I would really like 9:10. 9:15 is the limit. Okay? I did not change the quiz. It was not hard. All right, did I get a quiz paper to everybody? Ollie, do you only have 9? Okay, 'cause I'm struggling with the separations. Come show me. See if you're sitting there. Alright, 1, 2, 3, 4. This is why I'm struggling. Here, circle. That's why I was asking. I didn't want to cheat you out of anything. Hello, Russell.
First period, when we were fucking.
You were at the multicolor inks. Yeah, write your name on it. You missing one? Count for me. This could just be a separation issue that I'm struggling with here. That's why I asked. I don't know. I want to say you weren't here. Were you late one day or absent one day and something kind of thing?
No.
I don't remember either. Come in late one day?
I think that's okay.
Yeah. Come back, look in the dates. Today's that's in there will be the first one, so flip back to yesterday. And then go back, match your dates, since you got dates on yours. Or you can use Caroline's for the date. There, for the date. You should be able to match the work with what you have. See what's missing. Alex, you only have 9? Okay. It's Friday? Okay. Who's still working? But I do have some hands, okay. I'm surprised when everybody been done. hand these up to people. Done, Lana? I said, you're done? Hand out these. Yes. Just because they're handing out pictures does not mean you can talk. Don't lose your ID cards for those of you who don't have driver's licenses. You can use those for SAT, ACT identification. When you go to check in, lots of you are doing those types of things. It requires a picture ID. School ID is acceptable as a picture ID. So we either have people who didn't take a picture or it'll pop up later. Oh, while I'm thinking about it, Devontae, since you came in late, we took up the openings from yesterday. Since we forgot them. So if you've got those, bring them to me. Angel, did you not have any openings to give me? No, I'm talking to the one over there who's nodding his head back. But you just don't do them?
No, keep losing.
You keep losing them. All right. Yeah.
What if I got them all? Can I get them all and give them to you in the late grade?
Where are they at?
I got like most of them over there. I'll get them all and give it to you in the late grade. I give it to you now, and I can say, feel what I'm saying?
I feel what you're saying.
Yeah.
I won't hand them back, what's today? Wednesday.
Right.
I won't hand them back until Friday.
Alright.
If I have them by Friday morning before I hand them back, I'll give you full credit.
Alright.
But I won't hand them back until Friday. You have what issue? Same deal. Friday, when I hand them back though, you get no credit. You got me? I don't get them before I hand them back Friday. Might as well not hand them to me. All right, who's still got a quiz that they're working on now? We're at 9:12. So does everybody have answers down? Finish the quiz. Marvelous. Pass them to the front. It says diamonds up. She's going to collect them. You were up. Thought I'd take advantage of you. Well, I put these last two papers in the power school from detainees yesterday. Fourth. All right, let's just go that. Then, history. I can have Now we'll bring you sometime later today, at maybe after school. Because unfortunately, I have to go to occupational therapy during class, so it takes all those my entire time. All right, let's look at where we were yesterday. Okay, so yesterday we were talking about types of reactions. So that's what we're going back to. Okay. Told you I wanted it to percolate in your brains overnight. Hopefully it's done some percolating. All right, so yesterday we took notes and we said that single displacement had to be an element plus a what? A compound, and you get an element plus a compound. Now, when we go to start identifying these in a couple minutes, in order to be single displacement, how many plus signs do you have to have? 2. You got to have one on the reactant side and one on the product side. Now, how is that different from double displacement that we talked about yesterday? They're all compounds, okay? You still have 2 plus signs, but in double displacement, you have no what? You have no elements. Everything is a compound. Does that make sense to everybody? All right. Now, then we talked about synthesis and decomposition. They're the opposite of each other, okay? So, in this one, I wrote the equation as a synthesis reaction. So this, if you look at it, has no plus sign on what side? Has no plus sign on the right. Now, the flip of that is to write it as KCl becomes K plus Cl2. If I write it this way, now I've made it what kind of reaction? A decomposition reaction, because there's no plus sign where? On the left, okay? They're opposites of each other. I could just as easily have done it with this reaction and flip this one so it changes into that, okay? They're both able to be flipped. So if the plus sign is on the left, where you're adding it together, and there's no plus on the right, it's synthesis. But if there's no plus on the left, it's decomposition. Now, from there, we got to combustion, and we ran out of time. So we had written this down, and then we had to stop, right? So a hydrocarbon plus oxygen yields carbon dioxide plus water. And I told you this was my personal pet peeve. Drives me nuts when people get this one wrong. Because everything we've done up to this point, I said things like element plus compound, compound plus compound. You're looking for one plus sign, no plus signs on this side. Did I ever tell you what elements to look for? No. And I can't, because they're going to change constantly. With combustion, those are the only elements you're going to see. Okay? What does carbon's symbol look like? Hydrogen. How do you write oxygen? Oh, what? Okay, I thought that's what y'all said. Okay, so plus O2. And you get what? CO2 plus H2O. So this is going to be a C and an H, and the only thing that's going to change is what little numbers are down here in these bubbles. But that's the form for combustion every single time. It never, ever, ever changes. Okay? So it drives me crazy when people get it wrong. So why do people get it wrong? Well, they look here and they say this is a what and that's a what. They say that's a compound and that's a what. And then they tell me it's what? Sometimes. Some people look here and go, that's a compound and that's a compound, so they tell me it's what? But when you look at the whole equation combined, can it be double displacement? No, because are there 2 compounds here? No, that wipes out double displacement. In order to be single displacement, it's an element plus a compound, and you got to get an element plus a compound. Do you have that there? No. So that's why it's not those things. Now, those are just two examples, and I could literally fill the board, okay? They look like things that you've been balancing the last 2 days, and these are usually the ones that cause the issues in balancing. And I would guess before I even grade any papers, if anybody got any questions wrong out of 1 through 7, it's probably number 2, okay? Because number 2 was the combustion reaction. Everything else on that paper, I would almost guarantee I'm going to have all correct answers.
Do we have to put which of these it was?
You will have to probably tomorrow. Either tomorrow or Friday.
On another quiz?
Yes. All right. Does everybody have what they need?
No.
All right, we're there now. All right, so if I ask you very quickly, don't write all these down. I'm going to give you a sheet that has some examples on it. All right? Tell me the types. Could we do that? We could attempt. Okay? So very quickly look at those yourself and see if you can figure out what type they are. You need to make a note so that when I call on you, you remember what you thought it was. Yeah, use the abbreviations. Don't write the words out. And like I said, I have a sheet with examples on it, so you don't need to write all these down. I don't want this to take 15 minutes. What? I knew it had to be small. All right, got them? Yes, no? No. All right, how about now? Very nice. Well, you're gonna be excited when I hand this one back. I said you're gonna be excited when I hand this one back. Yeah, well, she hates my class, so it's important that she knows that today. All right, how about now? I don't hear your nose out there this time. All right, how many plus signs do you have in the first one? Only one. So if there's only one plus sign, that automatically limits your choices to what options? It's either got to be synthesis or it's got to be decomposition. It's got to be one or the other. It can't be combustion because combustion has 2 pluses. Single and double displacement has 2 plus signs. Since there's only one, it's either synthesis or decomposition. So, are you forming something or is it breaking apart? Okay, same thing in number 2. How many plus signs you got? It's either synthesis or decomposition. Which one is it? Okay, and number 3, there's how many plus signs? So you're either single, double, or combustion. Oops, that looks terrible. Okay, now for combustion though, what 2 products do you have to have? So that automatically eliminated that one out of the mix. So you either have to have 2 compounds or an element in a compound. Which one did you have? That's how you decide. See how you can eliminate? Okay. Number 3, what kind is it? Or 4? It's 2 plus signs. It's got an element and a compound, so it's single. Number 5, 2 plus signs. You got water and CO2. It's combustion. All right. Number 6. Double displacement. Number 7. And number 8. Single displacement. Are we okay with how to tell the types? Okay. Now, let's add some challenge. What? That was easy variety. No. All right. So today, we're going to start taking away the right-hand side of the equation. Okay? Remember, y'all got a test while I'm not here Tuesday and Wednesday. We can test Wednesday, and y'all can review some Tuesday while I'm not here. But I at least have to get through all the content while I am here. So, got to start learning to predict today. So looking at that, you got to be able to, and if you won't write these down, I'll give you a minute. So when you look at those, you got to be able to figure out, based on what we've just done, which type they are, just from that. Okay? All right, if I'm giving you long enough to write. All right, so when you look at the first one, what type would you tell me the first one is? All right, how would you know it's decomposition? Why would you pick decomposition for this one? There's no plus sign. Okay, when you look at it, there's no plus sign there. Okay? What would you tell me about number 2? All right, I hear synthesis and I hear single. One of the 2 is correct. Okay, to be single, you need what 2 things? Element and a compound. Do you have both? No, you don't have an element and a compound. You have 2 what? So if you have 2 elements by themselves, it has to be what? It's got to be synthesis. Okay, what about the third one? All right, why'd you pick single? It's got an element and a compound. It is single displacement. All right, 4 should, I think, slap people upside the head. All right, what's number 4? It's double. Look at all those elements. All right, those are 2 big compounds. So that's got to be double. All right, and last, combustion. All right, and this is the one that causes the most issues because if you don't recognize immediately that that's a hydrocarbon plus oxygen, people think what? What would you think they think that is if they don't recognize that's a hydrocarbon plus oxygen? And they get single because they see element plus compound. Okay, and that's one you have to recognize. Questions about how to get that far? Now, today we're going to start easy. We're going to start with single displacement and possibly do double displacement because they work the exact same way. We're not going to talk about the other 3 at all today because they're harder. But I'm going to show you some neat tricks. Okay? Well, they ain't all that neat, but tricks anyways. So, we're going to start with predicting products today. And we're going to begin with single displacement. Okay, we'll start with single displacement. Now, everybody knows that this is an element plus a compound. Now, what did we say was going to happen in this element plus a compound? 2 elements are going to do what? Mm-hmm. 2 elements switch places. Okay? That's what happens. So that's what we have to do. So how are we going to know which elements switch places? Okay? So when we do double displacement, the only difference is it's going to say compound plus compound, but it's still going to be 2 elements do what? Switch places. So these steps we're getting ready to write down are the same for both. We're not going to write them twice. Okay? So, number 1, determine oxidation numbers of each element. Okay? In order for us to know who to switch, we have to know their oxidation numbers. Now, in parentheses, I'm going to put here, you must know positive and negative. When we've been doing our crisscrossing, have we really cared who was positive and who was negative? No. But for what we're getting ready to do now, we need to at least know who's positive and who's negative. We're not actually going to use the positive and negative sign other than identifying it. Okay? Everybody caught up with me? Because I'm going to switch boards rather than make this teeny tiny. Do I need to wait on anybody? No? All right. So step 2. We're going to switch the 2 elements with the same sign. Either both positive or both negative. They won't both be positive and both be negative. Somebody will be the same. Okay? So we're going to switch the 2 elements with the same sign. Now, no subscripts go across the arrow or the yield sign unless part of the polyatomic ion. Okay? No subscripts go across the arrow unless part of the polyatomic ion. So when you switch them and put them on the other side, you do not take the subscript with you unless they're part of the polyatomic ion. Does that make sense? So if there's a subscript of 2, it doesn't get to go across. Unless it's like SO4. So SO4 is sulfate. So that 4 that's on sulfate gets to go across the arrow. Basically, when you look at the polyatomic ion sheet, if it's a subscript on the sheet, it gets to go across the arrow. But if it's not part of the subscript, it does not get to go. Okay? Number 3. On the crisscross, the oxidation number for the compound and check element for diatomics. And number 4, I should write balance, but what did we already say about all equations? They're all balanced, so I'm not going to write that. Okay? Now, the only thing that will be different in double displacement is that and. See how it says and check element for diatomics? Will there be any single elements in double displacement? No. Everything in double displacement is a what? Compound, so we're going to crisscross everything in double displacement. That's the only thing that makes double displacement different from single displacement. Single displacement has some elements, and we need to check to see if they have diatomics. But double is always crisscrossing. Everybody have what they need? Ready to try one? Okay. Let's say that we have SB2O5 plus AL. SB2O5 plus AL. All right. This is a standard single displacement reaction. It's got an element plus a what? Element plus a compound. Now, when you look at it, what's the first thing we need to do according to my steps? Find the oxidation number. So what's antimony? How'd you know it was a 5? You crisscross. That came from right there, right? So that's a positive 5. What's this one? Negative 2. All right, what's aluminum?
3.
Positive 3. Now, you're going to switch. All right, stupid. The positive elements. Now, I didn't say put the positive elements together, which happens a lot. We're going to switch them. So SB is going over here, and AL is going over here. Okay? They're switching places. Okay? So, what do I get on this side? AL with who? Do I have any polyatomic ions here? First of all. So what does it say? No subscripts go across the arrow unless part of a polyatomic ion. So did I have any polyatomic ions? Are any of those subscripts crossing the arrow? We're only talking elements here. So AL is going to be with who? Plus SB. Now, there's nothing wrong with writing SB plus ALO. It does not matter which order you wrote it in. Okay? Now, Last step.
How did you get that?
How did I get that?
Like, how did you decide that that's, what?
These two things are going to switch. So AL is going where SB is, and SB is going where AL is. They're changing positions.
So not just the subscript, the whole thing.
Huh?
Not, because you put the 5 with the, and 3 with the SB, right?
What are you talking about?
Like you said, you flipped them.
I did. All I did was switch their positions.
So you didn't change the subscript.
I haven't put any numbers in yet. That's what we're getting ready to do. All right. So on this side, this is step 3. This is a compound, right? Oh, let me change colors here. All right. This is a compound. What do we always do for compounds? You're going to hear me say this 100 times between now and Tuesday. Compounds do what? Crisscross. All right. Every time you have a compound, you crisscross without fail. All right. If it's an element, you do what? Exactly. You check diatomics. Sometimes the answer will be yes, it is, and you'll add a 2. And sometimes the answer will be no, it's not, and you will do what? Leave it alone. You'll do nothing. Okay? So when you look at ALO, that's a what? That's a compound. You have to crisscross. What are the oxidation numbers? They're right there. Aluminum is a 3. O is a -2. So I'm going to put them in. 3, 2, bring my 2 down, bring my 3 down. Okay? SB is an element by itself. Is it one of the 7 diatomics? So we do what to it? Leave it alone. Now, because I have all this junk in my equation, I need to rewrite this crap. So SB2O5 plus AL gives me AL2O3 plus SB. Okay? Now, who would I balance first? Wouldn't be my pick.
Oh.
So I'd go with. It's in both compounds and it's got larger subscripts, so that'd be my choice. So I have 5 and I have 3, so I'm going to put what here? I got a 5 and a 3 and I'm putting a 2?
Wait.
I'm doing oxygen. So I have 5 and 3, so I'm putting a what here? And I'm putting a, okay, so from there, I made how many SBs? So I can put a 6 there, and I made how many aluminums? So I'm putting a 10 there. All right, questions? Can we try another one?
Yes.
Okay. So let's say that we have, I don't know, let's do NiCl3 plus F2. Now let's do I2. All right, so what's the first step? Oxidation numbers. So nickel has a what? All right, chlorine has a what? Iodine has a what? All right, fluorine, chlorine, bromine, and iodine have -1, +1, +3, +5, and +7. You guys are in a first-year class. Every time you see it, it's going to be the -1, okay? It's never going to be those positive numbers that are on the sheet. So when you look up those 5 clear brown iguanas, it's -1. And I will say that a lot between now and next week, too. So -1. All right, so this time we're going to switch what? All right, you're switching the negatives. So the Cl and the I. So Cl is going to go here, and I is going to go there. So who is going to be paired with who on the other side? And I is going to be with the I, Okay? And then that leaves Cl by itself. Now, again, no subscripts because I don't have a what in this equation? A polyatomic ion. So, oxidation numbers. +3, -1. I bring my 3 down. Why did I do that on that particular thing? Why did I know to crisscross? It's a what? It's a compound. Okay? This right here is a what? Element. Is it a diatomic?
Yes.
We put a 2 there. Oops. All right, questions about that one? Can we do one that has a polyatomic ion in it? We can try. They're just as easy as those. These are not hard, are they?
Not yet.
They don't get harder. Single and double are the easiest of the 5.
It always gets harder.
All right, so let's say that this time, let's do Al2SO4.
So this is double displacement?
This is still single. We'll do a double after this one to illustrate the difference. Double and single are the same. They're the same. They work the same way, except you don't ever have to ask yourself, is it diatomic? Because they're all compounds. You'll always be crisscrossing. All right? So what's different about this one? It's got a polyatomic ion. It's got that SO4 in parentheses, right? Again, you're treating it as a whole unit. It doesn't work different. It works just like the Ca. It travels together as a pack. Okay? You keep it together. So what's Al's oxidation number? Okay, so +3. SO4 is -2. And calcium is? Okay. Now, who's switching then? The Al and the Ca because they're what? Okay, so we're going to switch the positive elements. Okay, so Ca is coming over here. Al's going over there. So what are we going to wind up with when that happens? Ca with who? Okay, let's do what Caroline wants for a second. Don't write it. You can write it down, but it's going to be a wrong answer. All right. Now, a lot of people do this, and that's why I want to point it out. Okay? A lot of people do it. When you put your oxidation numbers in, you have +2, +3, and -2. Do you see a problem? Why, Jada? There is a problem, but it should jump out at us. Okay? You can't have what, Alex? You can't have 2 positives together. It has to be a positive with a what? A positive with a negative. Okay? So when you put your oxidation numbers together and you look at them and you're like, I got 2 positives together. Can you have 2 positives together? No. That should tell you you did something wrong. Okay? So we don't put the 2 positives together. We switch them. So Ca is going to be with who? Ca is going to be with SO4. And notice, all I did, I kept the parentheses, and I brought the whole thing over. No, because the 3 is outside. You only get to keep what's inside, what's part of that polyatomic ion. This 2 and that 3 came from that crisscross of their separate subscripts. And then plus, my other element was what? Aluminum. All right, now we need to put our oxidation numbers in. So calcium has a what? And sulfate has a, now, a lot of people bring those down. What do we know about those two twos? I'm not bringing them down because they cancel out. Because once I bring them down, I'm less likely to recognize that they reduce. And then they're there screwing up my equation and my balancing. All right, aluminum is an element. What do I ask myself? Is it one of the 7? Nope. So I don't do anything to it. So Al2SO4 with a 3 plus Ca yields CaSO4 plus Al. Okay? So from there, we need a 3, 3, 2. And at this point, those easy ones like that, I know y'all know how to balance. So I'm just sticking it in there because I haven't hit a paper yet that was lower than 86. And I'm about half done. All right. Now, just to illustrate the difference, okay, we're just going to do one double displacement to show you how much it's just like it. Okay? Everybody got it?
Can I ask a question?
Sure.
So you did not put the Ca and the Al together because of the positive.
Because they're both positive. You have to have a positive and a negative oxidation number every time you write a compound. You cannot put two negatives together. You cannot put two positives together. Okay? All right. So just to illustrate double displacement. And I'm not going to write down anything for it because it works the same way. Other than to say what you already know. It's a compound plus a compound. It's the only thing that makes it different. So the only thing that's going to be different when we predict is, are we going to have to ask ourselves, are there any diatomics? No, we're not going to ask that. Everybody's going to crisscross. So let's say that we have CaI2 plus MnCl7. A nice easy one. I won't even put in a polyatomic ion. All right, so can we all agree that those are compounds? Okay. So Ca has what oxidation number? Okay. Iodine is a, Mn is a what? And chlorine is a what? Okay. So this time we have choices. You can either switch the positives or the negatives. Now, I tell people, pick one you like best. I always switch the positives. The way I did it in high school, I'm 48 years old. Sorry, I had to think for a minute. Get ready to turn 49. All right? You have to switch the one that you feel most comfortable with. I always did the positives. I still do the positives at 48 years old. Okay? So, if that's the one I do, stick with it. If you see it as the negatives, you switch the negatives and you stick with it, okay? So when I look at it, I see the positives. You look at it and you want to switch the negatives, go for it. You get the same answer. It doesn't matter.
Will you always have positives and negatives with compounds?
With double displacement, yes. Okay? So when I put in my products, Ca, when they switch, is going to be with who this time? Okay, don't put the two positives together. We're switching. So Ca is going here, and Mn's going there. So Ca is going to be with who? Cl, and Mn is going to be with who? I. Now, they're all compounds. If you wrote it as like Mni plus CaCl, it's fine. There's nothing wrong with that. All right, so they're all compounds. Don't need any diatomics. We just look here and get our oxidation numbers. Plus 2 minus 1, bring my 2 down. Plus 7 minus 1, bring my 7 down. And we have our compounds. So all we'd have left to do is what? Is to balance. Do you see how it's the same thing? It doesn't matter if it's single or double. It's the exact same process. All right, I better stop and hand out homework as slow as I am in these papers. Yeah, I can use help. Yeah, here, Lolly, since you're up. The one that Lolly is handing you is on types of reactions. You're gonna do all of those. You're just gonna tell me the types. The one that I'm handing you, first of all, it has two sides because I'm trying to save paper. We're only doing the front. We're doing the odd numbers. Everybody hear me? We're doing the odds. You're only doing 6. So no lining.
So all of this one are in the odd, right?
Yep. All of the types, and then the odd on the one that says predict product. And I haven't decided if your quiz on word equations and types is tomorrow or Friday. Okay? So did everybody hear me say that? I haven't decided if your quiz on word equations and types is tomorrow or Friday.
So you're gonna prepare the second one?
So the one Lolly gave you that says types, all, and the one that says predict products, only the front, and it's odd. And I will put that on the website. Hopefully during my planet period when I get back.
Cheyenne Slocum, please report to guidance. Cheyenne Slocum.
But you calculate